What is going on, everyone? In today's video, I will be showing you how to train your own YOLOv4 state-of-the-art custom object detector in the cloud, all for free. I'll be walking you through how I created a custom object detector for license plates, but you can create a custom object detector for whatever your heart desires. I'll be showing you guys how to gather your own custom data sets with ease, super fast. I'll also be showing you guys how to customize configuration files necessary to do this custom training. And I'll even show you guys how to test your custom object detector and see the accuracy of it in real time. If you enjoy this video, please don't forget to smash that like button and subscribe to the channel to keep up to date with all my latest YOLOv4 videos. It means a lot to me and it helps grow my channel. Let's jump right into the video. So in order to follow along properly with this tutorial, you're going to want to go ahead and click the link in the description of the video to the Google Colab. And when you open it, it's going to look exactly like this. And all you have to do is go ahead and click this copy to drive button right at the top. And you're going to go ahead and click copy to drive. And what that's going to do is save a copy that you can actually run of this Colab notebook in your own Google Drive. So if you don't have a Google Drive account, I recommend quickly setting one up. It only takes a couple minutes and then you're good to go. Awesome. So now once you have your own Google Colab notebook open, it comes the fun part where we can start to train our own custom object detector. If you were familiar with my last video, I went over how to run a out-of-the-box pre-trained YOLOv4 object detector with Darknet in the cloud using Google Colab. And I've left those cells and all those commands in here. So all of this part all the way down to how to train your own YOLOv4 custom object detector is from the previous video. So if you haven't already checked out that, I recommend checking it out. I'll link it up above and in the description below. So check it out and it'll show you a lot of cool commands and way to customize your YOLOv4 outputs, how to save the bounding boxes, how to save to txt file and all that cool stuff. And you can actually use all those commands with your custom object detector after we've trained it. So once you open up your Colab notebook, you're going to want to enable GPU so that it can accelerate the training and make it 100 times faster than without GPU. So you're going to want to go ahead and follow that step to do that right here. And then first things first, you're going to go to runtime and run all. And what's that's going to do is it's going to go ahead and download the repository with the code, as well as building Darknet so we can start to train our custom object detector. So it's just going to go ahead and do all the pre-configurations for you, and you don't have to do anything. You can just check that it's working by seeing that the cells have started to run. And there's a cell that says assert error or assert failure, and it's going to stop it there so that we can hop in and start to train our own custom object detector. For the sake of this video, I'm going to be training a license plate object detector to detect license plates on the back and front of cars and vehicles. So we can see that it's going ahead and building Darknet, which is perfect. And we're going to go ahead and let that run, and I'll come back once it's done all the pre-configurations. So if all went according to plan, and hopefully it did, you should see that in step 5, running your detections with Darknet and YOLOv4, we can successfully see that Darknet has been built by the fact that it is doing a detection on the pre-trained out-of-the-box model. And we can see that it is indeed working. It's detected the object within the image, and it's stopped on the cell which we wanted it to do. So now you can actually go ahead and you're going to want to do the next step, which is actually just connecting your Google Drive to your Colab notebook so that throughout the entire tutorial, you can use files and save files to your drive. So that anything happens during your custom training, you have the files, the trained, partially trained or fully trained model files saved to your Google Drive. Otherwise, you'll lose them if your Colab shuts down or for some reason you get disconnected. So you're going to want to go ahead to this method 2 of Google Drive, And we're going to go ahead and mount your Google Drive into the notebook, which allows us to access it. So you're just going to go ahead and click the link that pops up. Choose your account. Go ahead and accept the terms. And then just copy the key that it gives you. Head back to the notebook and paste it in. And then you should have your Google Drive mounted now in your notebook and have access to all the files within your Google Drive. So perfect. And then run ahead the cell underneath. This is just going to go ahead and shows me that it is indeed, I can see all the files and folders in the home directory here of my Google Drive. So it's working. And that's all you need to do for these steps. And then we're just going to CD back into Darknet. Don't forget this cell, otherwise you're going to be in the wrong folder throughout the entirety of this tutorial. I've seen that in my previous videos where it says Darknet is not a folder, and that's because you didn't do the CD command. So if that's ever the case and you see that error saying Darknet is a folder, not a file, just do CD Darknet right here. So now that we have our Google Drive mounted into the Colab workstation and we have access to our Google Drive, you can now skip to the now custom object detections, heading down to right here, how to train your own YOLOv4 custom object detector. And now comes the super fun part, guys. So you can create any custom object detector you want. You don't have to follow along with me. I'm going to be doing a license plate detector, so feel free to do so as well, or do any single class or object that comes to mind. And in order to create a custom object detector, we need the following: a labeled custom dataset, a custom.config file, object.data and object.names files, and train.txt and test.txt. If we're going to be doing a validation dataset, which we are, I'm going to show you guys how to validate your model and show that it's accurate. So we're going to go ahead and do all of these in this tutorial. So first comes the gathering and labeling of your custom dataset. This is probably the most important step of the entire tutorial, because without a good dataset, you are not going to be able to have a good and accurate model. It all comes down to the data. I'm sure you've heard that lots, but it is true. There's two ways that you can do gathering your custom dataset. You can do Google's Open Images, which is a pre-gathered dataset that has over 600 classes and millions of photos that are already labeled, which is awesome. And I use it for most of my videos. It makes it super easy. Otherwise, the second method is actually gathering your own images, either through Google Images or whatnot, and labeling them manually, which can be a very tedious task. And I have videos on both of these two methods. I'll pop them up above and in the description below, so you should see a link on screen if you want to choose and need more full tutorial and in-depth explanations of how to use these two methods. So the dataset, Open Images, Google's dataset, you can go to it, click the link, and explore, and you can actually see that there is going to be hundreds and hundreds of classes, and you can just explore this, and really there's like hundreds. You can see here endless opportunities that I've probably seen this in previous video of mine. And the one that I'm using, the class that I'm using, is vehicle registration plate, aka license plate, and I'm going to be creating this custom object detector. So by the end of it, it should be able to properly classify license plates and detect them within images. So a lot of cool applications with license plates, so that's why I chose it. And I know it's a beginner tutorial for a lot of people that in school is to do a license plate detector, so hopefully this helps you out. So we're going to use for this tutorial a toolkit that I've used previously in my videos that allows you to easily extract the images from this Open Images dataset and the labels and convert them into a YOLOv4 format, perfect for training a custom object detector. So I have a previous video where I showed on YOLOv3. The format for the labels and images is the exact same for YOLOv4. So this toolkit and that video is still extremely relevant and there's no changes to it. So if you want to check that video out, again, I'll link it up above and below in the description. And you can clone my repository for that, the AI Guys code OIDv4 toolkit. You just go ahead and clone this or download it, whatever you want. And it's going to have all the necessary files and steps for you. So here are the commands I'm using. So we're going to create first a training data set and then a validation data set that will be used for testing our model and showing that it is highly accurate. So this is my command I'm going to be running to gather my data set. I've already gathered my data set, so I'm just going to do a tester command here for you, where I'm going to change the limit to 15. So it's going to grab 15 images. In my full data set that I actually use for training, it's 1,500. So the more images, the better, I usually say. But you don't want to go overkill and do thousands and thousands for a single class. I'm only doing a single class object detector. Here you can actually do multiple classes. Just having them multiple classes. If you check my video, it shows you how. And you add the flag multi-classes 1, and it'll download all the classes of images into one file for you. And that's what you're going to want to do. But like I said, check out my previous video if you're doing it for multiple classes, and it's pretty straightforward. So we're going to go ahead and run this command, and it's going to go ahead and download 15 images. Ooh, here we go. This means it's properly working. If you can see the YOLOv4 downloader, it's going to go ahead and download 15 images as my training data set. But like I said, I've actually done 1,500 for my actual detector. So it's downloading the 15 images. And then after that, we're going to do the same thing, but for a validation data set. So for type CSV in the first one, it's train for the training images. So the actual open images data set has certain images it keeps for training and validation, which is perfect for us. The training data set is or type is always the larger data set. So I think this one has thousands and thousands of images for license plates. I'm only taking 1,500. And for validation, I took 300. It's recommended that you take anywhere between 20 to 30% of your training dataset size and use that as your validation dataset size. That's pretty common in artificial intelligence and machine learning in general. So that's what I did. 1,500 for my training dataset, 300 images for my validation. So let's see if it's perfect, if it's got my training dataset. Yep, it has. And we're going to run the same command, but I'm just going to show you as an example, my limit set to 3 instead of 300. So it doesn't take a long time, because downloading 1,500 or 300 images can take a while. So don't be alarmed if it takes a couple of minutes, several minutes to download all the images. And then I'm going to go into where I cloned my repository. So you're going to go, this is the root folder, void, dataset, and you're going to see that I have a train and validation. So my training has my images with my license plates, and the same for validation. It will also have, and it has 3 images and the labels. The toolkit raw doesn't have the labels in the proper YOLOv format. So that's why I added to this toolkit this convert annotations that goes and actually transfers all the annotations into a proper YOLOv4 format for you. So the next step, once you have the images, you're going to want to check this out, and it's going to convert them into the proper labels. So what you do is the classes.txt in the root folder right here. You're going to want to go ahead and open it up. And once per line, whatever classes you have for your detector, you're going to want to go ahead and put them 1 per line. So I only have 1 class, vehicle registration plate. But let's say I had elephant, I would put elephant on the 2nd line. If I had giraffe, I would do giraffe on the 3rd line. So 1 class per line, and however many classes you have decided to create your detector for, that's what you're going to want to do. So I'm going to go ahead and delete that. Not going to save it. So I showed you here for multi-classes, this is what it should look like. And so I have vehicle registration plate. And now I can go ahead and actually run the Python convert annotation script, which goes ahead and does it for you. It actually converts all of the labels into YOLOv4. Should work. There we go. So once you have your classes.txt saved, you're going to have, it should show you that it's gone through both directories when you run the command for convert. It's done my train and my validation. So now if we go back to our data sets and we look in the train, it should have a text file for each image, and that's the proper YOLOv4 format. And if you check, it should have the class. This should be the class number of what line it's on, starting at 0 in that classes.txt. So all of mine should be 0 because I only have 1 class. So this represents that it's license plate, and this is the coordinates. So that's the proper format. And then once you have the proper format, you can run these 2 lines to go ahead and delete those old labels. So you can either run that command, or you can just go in here manually and delete the old labels because we don't want them in our data sets anymore. So I'm just going to show you guys how to manually do it. You just go in, right click, and delete both. So you can do that, or like I said, you can just run these commands within the PowerShell. So now that you have our data sets properly formatted in the YOLOv4 format, we are good to go, and that's our data sets. But first, you're actually going to want to go, once you're done this is the second way, method 2, where I manually set it. I'm not going to go over that, but once again, there's a video on that I have on my channel. So check it out if you're going to manually label your data sets, because you don't have the classes you want in the open images. I recommend checking open images first. If you don't have it, then resort to manually, because it does take a heck of a lot more time. So now that we want to move our data sets into our Cloud VM so that we can access it while training, look in here. So what we have to do is we go back into our data sets. You're going to want to rename your training data set. So right click on your training data set folder, rename, and call this object. That's going to be our training data set. And then we go to validation, and you're going to rename this one test. That's going to be our test data set. So once you've done this, you're going to go ahead and zip both of them. So compress them so that you can upload it to your Google Drive and it doesn't take gigabytes and gigabytes. So just go send to, I'll show you that again, right click and go send to, compress zip folder. And there we go. We now have our object zip, and we'll do this. You do the same for validation. Right click on it, send to, compress zip folder, and it's going to compress all the images. And then you just go to your Google Drive. I recommend a YOLOv4 folder for all of these files. And if you want to see what I have in my files, I will actually have it uploaded to my repository for YOLOv4 cloud tutorial. And I actually upload all of my files here, not my training files because, my data sets, because they are hundreds of megabytes, but all of my configuration files that you'll see later on are here. So if you get stuck, you can check mine. But yeah, so you're going to zip them up, and then you're just going to go ahead and drag them. Just click it and drag it into here. I've already gone ahead and done that. You can see I have my object.zip and my test.zip of my 1500 images and my 300 images. So we're good to go. We've moved it over into our Cloud VM, and then, or we haven't moved it into our Cloud VM, we moved it into our Google Drive. And now you're just going to go ahead and run these commands, and they're going to actually copy your object.zip and test.zip into your Colab workspace, your VM, and then you're going to unzip them so that they are not compressed, and now they're at full size within your Cloud VM so you can access them for training. So we've gone ahead and done that, and as you can see, it's unzipping and inflating all of our training images and our validation images. So that's perfect. And now for step 3, it's configuring all of those files that I just showed you in my repository, generate object config for our custom training. So you're going to run this command, download the config file. It's going to download the out-of-the-box config for YOLOv4 and rename it as YOLOv4 object config in your Google Drive. So now I can see it. It's saved to my Google Drive, YOLOv4 object config. And this is going to be where you configure all the parameters for your custom object detector. There's quite a few parameters you need to configure. If you're doing it on the local machine, you can just run this command to download the file. But now it comes time. So this is where a lot of people make mistakes and they make typos. If you make a typo here, it is going to affect your training and it might not work. So you're going to go ahead and carefully use all these equations that I've set out for what you should be having in your .config file for your custom object detector. It changes depending on the number of classes you have, and just kind of what kind of accuracy you're looking for. There's certain things you can tweak to make it more accurate or less accurate and speed up training. So you're going to want to check this out very thoroughly, but I'm going to go ahead and show you mine. So you're just going to go ahead back to your Google Drive, wherever you just saved the .config, and you're just going to double click on it actually, and then go open with, and you should have a text editor. You can just use the text editor within Google Drive. It works perfectly. So here we go. So you're going to want to have batch set to 64 and subdivisions to 16. That is what it is for training. for just running your object detector, you'll see later that you're going to run on the testing for batch equals 1 and subdivisions equals 1. But for training, you want batch 64 and subdivision 16. For myself, I like to have my width as 416 by 416. That's what I kind of see as standard. If you play with this width and actually increase it, accurate object detector, but it takes a lot longer to train. So I find 416 kind of the optimal. If you're running into issues and it's not as accurate as you want, this is one of the things you can tweak by upping it by factors of 32. It has to be a factor of 32. But as you saw, it was, I think, 608 before. You can have 608 by 608. Channels equals 3. That's for if all your images are RGB. But if your images are grayscale, you might try changing this to channels equals to 1. The next thing you're going to want to change for your parameters is your max batches. So your max batches, you'll see that I have the calculations here. It should be set to number of classes times 2,000. So if I'm training for 3 classes, it's 6,000. If I'm training for 5 classes, it's 10,000. But you can't be less than 6,000. So if you're training for 1 class, 2 classes, or 3 classes, this will all be set to 6,000, just to allow enough training iterations to get an accurate model. So I'm only training 1 class, but like I said, the minimum can be 6,000. So I'm going to put 6,000, and then you're going to change your steps. The 2 step values should be 80% of the max batches and 90% of the max batches. So if I go back and see here, my 80% is 4,800 and my 90% is 5,400. So like I said, I'm going to set this to 4,800. That's 80% of my 6,000, and 90% is 5,400. So steps is now changed. That's perfect. And now comes one of the trickier ones to do. You're going to want to just Control F and look for classes within here. So you're going to get classes, and you're going to change this to the number of classes you have. I'm training for 1. And then here is the trickiest change to make. Filters in the convolutional layer above the YOLO layer where you just change classes. So you change classes in the YOLO layer, and in the convolutional layer directly above it, you're going to change the filters value. Filters value should be changed to this equation right here. Filters equals number of classes plus 5 times 3. So for my 1 class, it's number of classes is 1, plus 5 is 6, times 3 is 18. But if you're doing 4 classes, then it'd be 4 plus 5, 9, times 3, 27, and so on. So make sure you do the math properly here, and you can't just write number of classes plus 5 times 3 in your config file. You have to make sure that you set it to the proper number. So mine, like I said, is 18. And you're going to do this for all 3 of the YOLO layers and convolutional layers. So you can see there finds classes 3 times within this file. So you're just going to search through, go to each one, classes equals 1, and filters in the layer above, 18. So for the third one, classes equals 1, and filters equals 18. And then you're going to go ahead and just save the file. And that should be it. Those are the changes you need to make. So to go over them again, your changes, you need to set batch equals 64, subdivisions equals 16, your max batches and your steps, your width and height, depending on the accuracy and how long you want training to take, adjust those. And then filters. So there's kind of 7 to 8 things that you need to change within this file. And I also made a note here that if you're running into memory issues with your training and it keeps closing your notebook or it keeps crashing, one of the things you can change is an additional parameter in this config is where it says random. So instead of random equals to 1, you can set random equals 0. And that's going to go ahead and not allow, for during training, random equals 1. It will scale up your width and height depending by a factor that it generates. So it could scale it up for larger images and lower for smaller images. So it gives you a variance of what the image size is. So your model is better to seeing different sizes of images. But by setting random equals 0, it makes every single one set to 416. So nothing can get scaled up and cause for more memory to be taken. It keeps it at the same level. So that might be confusing, but if you're getting crashes of your notebook, and training isn't working, that is something you can change. So change that. But now we have our custom.config file, and we're going to go ahead and copy it back into our notebook. So we exported it as the old one, made the changes, and now you're going to import it and upload it back into your notebook to use. The second files that you need to change are your object.names and object.data files. You can see mine that I use within my repository right here. So you can look at those and use them as a reference. But I also show images here of what you need to do. Your object.names is going to be exact same as your classes.txt you use for the toolkit. So one class per line. But here I've changed my vehicle registration plate is what it was called in the Open Images dataset. I've renamed it license plate. So as long as you keep these in the same order as your classes.txt, you can rename them, but they have to be in the same order because that's what the label will point to. So the label will point to here and show the correct class name. So license plate is what I'm calling my vehicle registration plate. So secondly, you're going to create your object.data file. This is the file that the training uses to point in the proper areas for all of the parameters it needs. So the number of classes, your training data set, your validation data set, your names files, and where it's going to save your weights files. So the backup is one of the most important ones. You're going to want to set this into your Google Drive. So earlier you created a link, My Drive, so that's your Google Drive. And then this is the file path to where you're stored. So if I go to my drive and go back, you can see that in my drive, I have a folder called YOLOv4, and you're going to want to go ahead and create this folder right here, backup. You're going to want to create backup, and in here is where all of your partial weights throughout training will get saved. So if anything fluke accident happens, it crashes your notebook, all the weights that you were saving, let's say you trained for 3 hours and it wasn't finished, they'll still be saved here. So I cannot stress enough how important it is to use this backup as in to point to your Google Drive. If you just pointed it to /backup and not this first part, it would just save in your Cloud VM. And if it crashed or something happened, you would lose it and you would have to retrain from scratch. So guys, cannot stress enough the importance of that. Create a backup folder and point to it here in your Google Drive. So we're going to go ahead. I've uploaded both of those files, my object.names and object.data, into this YOLOv4 folder I have right here. So you guys are going to want to go ahead and create those and do the same. Just create them in a text editor. You can even do it within Google Drive's text editor like I showed you for customizing the .config. Just open it up and do it there. And then this command just copies them back into your folder. So this is going to go ahead and bring them back into the Cloud VM to be used on the training, copies them in. And finally, the last part of the configuration we need is generating this train.txt and test.txt. So you can access the scripts from the GitHub repository. You can see that right here, these two scripts. They are going to create the files that our training looks at for the image paths. So train.txt has all the image paths for all of the training images, so it points to all of them. And then test.txt, which will be created, will do the same for all of your validation data set. And it's just one of the things YOLOv4 needs for the custom training. So I'm going to copy them both in. I have them saved in this file or this folder, and then I'm copying them in just to the root repository. And I'm going to run both. Let it run, and that's going to go ahead and generate your two .txt files for training and testing. And then we're going to go ahead and verify it. You're going to want to make sure that when you created your data sets, you called them obj and test, or else this might not work, these two scripts, because I have hard coded it for object and text. And you can see we have test.txt and train.txt. If you had run that command before, they wouldn't have been there. They just got generated. And inside the contents of train.txt should be like this. And same for validation, but it would be test. And it just shows you that it has the path relative to where you are in your file structure to the images that you're going to be training on. And that's perfect. And now you're going to go ahead and final step before training, download the pre-trained weights for the convolutional layers. So you think of this as kind of doing some transfer learning almost. So you're going to take these base weights for all of the layers in the YOLOv4 architecture, and you're going to start your training off of these optimal weights. So if you didn't use these, you would have to do it from scratch, and it would take the learning a lot longer, heck of a lot longer, and it would not converge as fast. So by using these as like a Kickstarter, it allows your model to converge and be accurate much, much faster. So yeah, we're going to go ahead and use those to our advantage, and you should as well. So now comes the time that we have done all the pre-steps, pre-configuration for training our custom object detector, our license plate detector. So now we can go ahead and actually run the commands to train. So before we do it, there's this one trick that I have that you can copy and paste this code into the console of your Google Chrome. It works on Google Chrome. I'm not sure about Edge or Firefox. So you're going to copy selection. So by default, Google Colab has a 30 to 60 to 90 minute, depending on where you are in the world, time frame before it kicks you off. And if you're training this custom object detector, it could take several hours, and you might not want to be at your computer. You might want to go have lunch, go to work, and come back and still have it running. But by default, Google Colab will kick you off after a certain amount of time of being idle. Like I said, it varies. So by doing this little hack in your console window, it's going to go ahead and make it Google Colab believe that you're still there by simulating a click every couple minutes. So it's just a hack I created to bypass the kicking it off. So we're going to go inspect, go to the console. I can just clear this. And then you're just going to paste it in, the function that I just showed you. So I just clicked it in here and click enter. And that's going to go ahead and simulate a click. And that should keep your Colab notebook open and running. Another thing you're going to want to go to do is go to power settings, power and sleep settings on your computer, and change this to when plugged in, turn off never, when plugged in, turn it off never. And you're going to want to do that because you're going to want to plug in your laptop and have it run for several hours while you're training. And if you don't have that, your laptop might shut off or hibernate or go to sleep during your training and stop it and kick you off your Google Colab. So you don't want that. So just do that for the purpose of this video while you're training, and then go back and change those settings back. So now we have our detection, our training cell. You can just go ahead and make sure that these point to your proper paths. So you're going to want to do Darknet detector train data object data config YOLOv4 obj, and then that pre-trained weights on the convolutional layers. The flag don't show will suppress a image from showing up, showing you how your model is doing. That will cause the notebook to crash because Google Colab doesn't natively allow you to show images. And then this .map flag, delete this if you don't have a validation data set. This is just going to show on a chart as it shows the iterations and the loss. It will also show you your mean average precision on the graph as well. So we're going to go ahead and run that. For some reason as well, you get memory errors during your training. You're going to want to go ahead and uncomment this line right here, and that will suppress this window or this cell from outputting anything. As you'll see, it outputs a lot. So you're going to want to go ahead and run this only if you run into errors of crashing during your training. Otherwise, leave it because you want to be able to see your loss throughout. So it's going to go ahead and start training just like we want. And I'll show you guys here. This is the random coefficient that I talked about earlier. If you set it to 0, it won't do this, but having it set to 1 allows you to scale up and down your width and height. So we're going to see it now. It's working, it's training. This is what you should see. And if I scroll up, it shows the number of training iterations. That's 1. It has a 1 and shows you the average loss on screen there. So we can actually scroll down. So this is number 2, training iteration 2. We set it to 6,000. So just imagine how long this might take. It's at 2 right now. And the loss is super, super high. It's almost 2,000 our loss. But we want that to get down under 5 and ideally under 2. And even better would be under 1 for a very accurate model. So this is going to train for probably an hour, a couple hours or two, a couple hours or more, and you're going to see that this loss is slowly going down already. It's going to go down quite fast at the beginning and then start to slow down as the model takes longer and longer to train and get more accurate. So I'm going to let this train for you guys, and then I'll come back and show you once it's done. So I've gone ahead and I've actually stopped the execution of my training just because I wanted to go ahead and show you guys a couple of things that happen throughout the training process that you should be aware of. So you can see I stopped it after about 220 iterations, and you can see that my average loss has already gone down to under 2 from close to 2,000 like it was. And it still has about 6 hours left on training. So that's a crazy amount. It's gone down a ton, but it still has 6 hours left to get to that 6,000 iterations. And one thing to note is that the way the Darknet and YOLOv4 works is that every 100 iterations of your training in wherever you classify in your object.data folder or file as your backup, it's going to go ahead and save a weights folder. And this is the file you use to run your object detections. So every 100 iterations, it'll save resave this file. So this is the file that saves every 100 iterations. And every 1,000 iterations, it will save a brand new weights file that will be YOLOv4 underscore 1000 for the 1000th iteration, a new one for underscore 2000, and so on. And then once it finishes, it will have one called final.weights. So I wanted to point that out because you can actually stop training halfway through or 3/4 of the way through, test out your different weights files, see if you need to continue on, and move on from there. So during training, there's this chart.png that gets saved in your root darknet directory right here, chart.png, that shows how your model is doing. So I'm going to go ahead and open that up for you guys. And as you can see, I'm not anywhere close to being done my training because it's going to show. But as you can see, this is where it's saved. So this was saved at the 200 iteration mark. So my loss was just above 2, it shows. And see how fast it's dropping. So the model can actually get trained really quick. And then around here, it starts to level off. And it'll start to just overfit at that point. So if I actually look at the official Alexi AB Darknet repository, the founder and creator of YOLOv4, you'll see that this is what you're aiming to see by the end of your training. So you shouldn't stop it early unless you're fairly certain that you are starting to overfit. So I'm seeing that mine's following this trajectory of quickly going down, and then it's going to steady off. And after 1,000 iterations of training is when it starts to plot, every 1,000 iterations, it plops your map value. So you can see that it went up quickly, and then it starts to peter off, and it matches up with the loss. And the accuracy does not increase that much, and the loss is barely going down. It's going up and down, back and forth, so that you can decide where your best weights file would be, so that you don't overfit your model. So I'll show you another graph here. I'll blow it up and show it on screen. But you want to find the spot right here, the early stopping point, where you're no longer getting a better model for the amount of training you're doing. So if I was looking at this model, I would say that around the 4,000 or 3,000 training iterations, that would be your final and most optimal weights file to use, because you're getting thousands and thousands more iterations of training, but you're barely seeing any production and accuracy and any decrease in loss. So I would say that that model is being overfit. So the perfect ideal weights would either be 3,000 or 4,000. So I'm going to show you guys how to test that as you go through. So you're going to want to let this run and fill out. I stopped it early to show you guys this, but let it go fully. If for some reason your crashes and your notebook crashes and you lose this chart.png, don't worry. I'll show you guys as well how to see the map values after the fact of training. So this is just what I said. It saves every 100 iterations, and you can actually kick off training again once it crashes or once you stop. So that is why we save in this backup folder, so we have the weights saved and can kick off iterations, kick off training again with the last saved weights. So if I ran this, it would actually just kick off training from where it just left off. So we're going to go ahead and see that it's starting up again. And let's see the training iterations number. Let it go for a sec, load in, and it'll see that it's probably at 200. So let's check. It's loaded. Yeah, 201. So it saved every 100, and my closest 100 that I stopped it at was 200. So it's kicking off training from that 200 point, and it's going to keep going towards that 6,000 iterations. So it's going to keep going. And then I'm going to let that run and finish off. But I just wanted to show you guys that. All right, guys, I'm back. I've let my model train a lot longer for a couple hours. And I realized that you'll see that here I was saying every 1,000 weights it saves a new file, and then every 100 does the last. I trained for just over 3,500 iterations, and I noticed that since around 2,000 area, my model was definitely getting overfit. My average loss wasn't going down at all, really. So I cut it off early and deemed that my model was properly trained. So now I'm going to check the map values and see which one of my weights actually works the best. So yeah, you can cut it off early if you see that the loss isn't going down anymore. It's just staying same. For hundreds of iterations, it's staying around the same. But for beginners, I'd recommend just letting it run to completion and then testing out each of your folders. You can point to each weights file within the folder and test them all to see which one's better. And I'm going to show you guys how to do that. So this cell here, step 6, is checking the mean average precision of any of the weights files and comparing them to see which one is the optimal one. So we just go ahead and run this cell and point it to whichever weights file you want to check the mean average precision of. I'm checking it of the last one. So we're just going to go ahead and run that. And it's going to go ahead and print out what the mean average precision is. And then we can compare. So we'll just let it run. It's going to take a couple seconds here to do the calculations to see what the average precision is. So here we go. Mean average precision is 88.57%. That's pretty solid model. Hopefully you want to try to get it into the low 90s if possible, but this is very good and it will do the job just fine as an object detector for my license plate. But I'm going to go ahead and change the point to a different weights file. So I'm going to change it to YOLOv4 obj_1000 dot weights, and I'll show you that it will be a different value. So change it to 1000. And if ideally we would want this to be a smaller map value because it should be less trained and have less accuracy because of that. So hopefully it shows a smaller value. We'll let it calculate it up. And we can see that at 1000, our accuracy, or mean average precision, I should say, is only 77.67%. So a whole 10% of less precision. So that's quite a lot, in fact. And we can see that our last one is a lot better. So you're just going to want to do that for each of the weights files throughout your training. And then you're going to want to take the one that is relatively high and it doesn't show much change between them. So for example, my YOLOv4 object last weight was about 88. And let's say my 2000 was 87 and 3000 was 88. Is 1000 extra training iterations really good enough to get that 1 extra percent? Is that worth it? Or would you consider that overfitting because it trained on so many more images just to get that 1%? So ideally it's just trial and error, play around with, and I'll show you how now, how to actually test it out and see it on images. So now it's time to actually run your custom object detector. All you need to do is run this line to change those 2 lines that I showed you earlier in your .config for batch and subdivisions back to the testing ones, so they get set back both to 1. And now we can go ahead and run our object detector on an image. I have 2 images, 2 car images with license plates that I'm running it on, and imshow predictions.jpg outputs the saved image. So we're going to go ahead and I'm running it, like I said, on my object last weights, the last saved weights. And let's see if it worked. And it did. It worked extremely well. My custom object detector seems to be working. It detected the license plate almost perfectly around it. I'm going to try that again on the second image I curated. So I'm going to check that on car2.jpg and run it again. And hopefully it can do it again with extreme accuracy. So let's check it out. 93% accurate of detecting the license plate. And it did it in 33 milliseconds, so extremely, extremely fast. And once again, it has worked almost perfectly. Almost, like, see how tight that is around the license plate? It's extremely accurate on detecting the license plates. So I would deem this to be successful. And yeah, that's pretty much it when it comes to training your custom object detector. If you have any problems whatsoever, please comment down below and let me know your issue, and I'll try to help you out. But I hope you enjoyed. Just a reminder that if you now want to use your custom object detector on video, or use it on multiple images at once, or to output to a text or JSON file, you can do all of this using my previous video, which you can find the code and cells in the top half of the notebook you just used for custom training. So once again, just a reminder, use my previous video to do all those cool functions. And if you enjoyed this video, please toss it a like and smash that subscribe button to be up to date with future videos covering YOLOv4 and object detection. Thanks. Bye.